Critical thinking, from intuition to structured methodology. The transition from reactive intuition to deliberate methodological rigor is presented as an urgent foundational necessity for modern organizations. In order to successfully navigate the complexities of business, it is essential to employ structured intellectual competencies and psychometrically validated cognitive skills, such as those defined by Facione. The argument is made that organizational culture must shift from a reliance on intuition to an evidence-based approach sustained by systematic Socratic questioning habits. This theoretical framework facilitates the formulation of defensible arguments, even within high-stakes, uncertain environments. It is therefore imperative to recognize that critical thinking is a mandatory skill.
The crisis of expertise in the algorithmic age. The modern era is characterized by a saturation of algorithmic persuasion, which contributes to a severe erosion of independent human thinking. Risks associated with cognitive offloading are identified in tech-driven environments, where there is an over-reliance on automated machine recommendations. To combat the accelerating crisis of professional expertise, it is necessary to detect plausible-sounding falsehoods and AI hallucinations. The reclamation of cognitive autonomy from opaque algorithmic black boxes is established as a critical objective.
3 epistemic traps in tech teams. Within technical teams, 3 primary epistemic traps are identified. The first is confirmation bias, which involves actively favoring validating data while ignoring crucial disconfirming evidence during product launches. The second is the anchoring effect, where practitioners fixate on initial algorithmic outputs and fail to adjust estimates despite new information. Finally, automation bias describes the inherent trust in machine-generated logic, which can lead to the suspension of human critical evaluation and the masking of proxy discrimination in training data.
Popper's antidote: falsification over confirmation. Karl Popper's principle of falsification is presented as an antidote to cognitive biases. It is suggested that confirmation bias be challenged through the aggressive falsification of hypotheses and the active hunting for data that disproves preferred business strategies. Rigorous tests must be constructed to break fragile team assumptions. By applying Facione's evaluation criteria, logical strength is assessed to distinguish between warranted and unwarranted claims, ultimately transforming fragile hypotheses into resilient theories. Kahneman's dual system cognition. Cognitive processes are categorized using Kahneman's dual system model. System 1 cognition is fast, intuitive, and effortless, yet highly susceptible to flawed heuristics and algorithmic persuasion. In contrast, System 2 is slow, analytical, and deliberate, serving as the essential safeguard against rapid decision errors. Although System 2 requires significant cognitive load to maintain, it allows for the employment of rational, reflective truth-seeking models, such as those proposed by Ennis. The principle of charity. The principle of charity dictates that opposing arguments should be reconstructed in their strongest possible form. During team debates, immediate adversarial reflexes are suspended in favor of deep intellectual empathy for conflicting viewpoints. This approach avoids strawman fallacies and identifies valid premises within rival technical proposals. Following Paul Elder's standard of fair-mindedness, team discourse is elevated beyond zero-sum ideological battles. Case study: AI champion versus quality engineer. A comparative analysis reveals the differing priorities of the AI champion and the quality engineer. The AI champion prioritizes rapid deployment and output volume, often outsourcing core reasoning to machine learning models, despite the risk of hallucinations. Conversely, the quality engineer demands strict verification and falsification. The engineer applies Paul Elder intellectual standards to machine claims and audits training data for embedded proxy discrimination to maintain fierce cognitive autonomy. Epistemic virtues is considered essential for disciplined thinking. These include intellectual humility to recognize personal blind spots and intellectual courage to challenge flawed consensus. Fair-mindedness ensures all viewpoints receive equal scrutiny, while intellectual integrity demands the application of strict standards to oneself. Furthermore, perseverance and inquisitiveness are required to navigate complex data and prioritize factual accuracy over ego preservation.
Arendt's warning: the banality of thoughtlessness. Drawing from Hannah Arendt, the grave ethical risks of automated decision-making and the banality of thoughtlessness are highlighted. Passive compliance with biased algorithmic directives must be resisted, and the delegation of moral judgment strictly to code is refused. By applying the MAGE framework to human-AI collaboration, practitioners can identify hidden societal harms and protect human dignity against invisible statistical categorization. Vigilance against the normalization of cognitive laziness is maintained. The outsider test, revealing blind spots. The outsider test is employed to reveal cognitive blind spots by stepping entirely outside internal corporate belief structures. Strategic decisions are analyzed from a detached, alien perspective to expose foundational assumptions embedded in project scopes. Evidence sufficiency is evaluated using Fassione's objective criteria, and internal metrics are triangulated against external realities. This process includes auditing machine learning models for narrow or localized cultural biases. Metacognition, observing the cognitive process. Metacognition involves the real-time observation of internal reasoning patterns. This practice enables the detection of personal susceptibility to the availability heuristic and the deployment of Fassione's self-regulation skills during negotiations. By pausing deliberately before finalizing judgments, practitioners can track the specific cognitive biases influencing team dynamics. The documentation of shifting assumptions in an intellectual portfolio builds lifelong habits of intellectual self-correction. Structure of a critical decision matrix. A structured decision matrix is utilized to provide clarity and precision. The process begins by explicitly defining the overarching purpose and formulating the central dilemma without ambiguity. Data credibility is assessed using Ennis's strict criteria, and factual premises are distinguished from unverified values. Furthermore, the governing theoretical frameworks and the logical consequences of proposed actions are clarified, while acknowledging the limiting context of the observer. Interactive audit, logical fallacy bingo. Rigorous auditing is required to identify logical fallacies within organizational discourse. Common errors include ad hominem attacks on developers, straw man misrepresentations of competitors, and the false dilemma between speed and quality. Other fallacies to be monitored include the slippery slope regarding minor bugs, the appeal to authority concerning AI creators, and hasty generalizations drawn from limited dataset samples. 5 principles for daily practice. 5 principles are proposed for the daily practice of critical thinking. These include the rigorous application of Ennis's Frisco model to daily uncertainties and the demand for conceptual clarity before establishing consensus. Machine recommendations are interrogated using Paul Elder standards, and empirical evidence is strictly separated from subjective values. A team culture of Socratic questioning is cultivated to balance technological efficiency with unyielding human cognitive autonomy. Foundational literature and residual uncertainty. Final strategies are grounded in the work of Fascione, Kahneman's behavioral economics, and the NIST AI risk management framework. It is necessary to acknowledge the fundamental limitations of large language models and the discomfort of perpetual intellectual uncertainty. Cognitive tools must be continuously adapted to evolving algorithmic opacity. The inquiry concludes with a focus on how teams will secure their cognitive autonomy in the future.